So we're here because we would like to start the series of our open days. We are the program called Science of Learning and Assessment. It's a master program, 2-year, full-time master degree program. And we would like to briefly describe what you will have as an experience on our program and why it's a good idea to enroll, or maybe why it's a bad idea to not enroll. Because we follow the spiral curriculum, I will start with a very brief description of what I think is important, and then I will ask Maria Salidou, who is a head of this master program, to highlight some moments. So, if we speak about our program, we should remember that we are still a new program. It's been the first year when we are teaching the first bunch of our students. This program was merged with 2 previous programs. The one is Measurement in Psychology and Education, and the second one, a Developmental Science program, which was a new program. So it's like a new program with very old roots. We have many budget places, and we invite people who want to focus on developmental science and psychometrics. Before, we were speaking about 2 tracks, because among us, we couldn't decide how to divide people. And we believed that psychometrics is a special field and developmental science is also a separate field of study. But of course, we wanted to unite them, but no one believed it is possible. But now, when we are teaching the first group of students who were enrolled last summer, we realize that those who wanted us to have separate tracks were wrong, because our ideas were true, and we really can have people who enjoy both psychometrics and developmental science. For example, we have a student who writes her thesis, her master thesis, about a new scale. She creates a new scale, she develops it herself, and it's a purely psychometrics type of work, a new scale development. But at the same time, she invests all her time into learning about eye tracking techniques. And right now she is being at her second course in Sirius University, learning how to use eye trackers for different purposes. And this is a good example of how measurement and neuroscience, developmental science could be united within one person, one field of interest, one student's trajectory, and maybe in the future it will be one academic career. And we have many students like Alisa who are interested in both fields of studies. Our goals, I am sorry for this ugly typo. Our goals are teaching about cognitive development, teaching about conducting educational research, and of course, teaching about psychometrics. Psychometrics is a science where which helps us create tests, exams, and so on. This is a slide which we liked to show previously, but this year...
Ina, your slide is stuck on the second one.
Oh, that is a problem. So let's see now. Chapter 5. So this is what I was saying about 2 tracks, which are not separate at all. This is what I said about solo goals, and again, it's stuck again. And this is what I showed previously, but this year we changed our rules of game, and we allow students to study both offline and online. It means that this is the first year when students can participate in our full-time, remember about full-time program, from their home city, hometown, from another country, or they can come to Moscow and go to lectures and seminars offline, participating offline. So a group of students come to this Institute of Education in the center of Moscow and study there. The other group of students who, to some reasons, don't want or cannot come to Moscow, join us online. We have special rooms with videos, with large screens and so on. And it is quite comfortable to have 2 groups of students. We have students in Kazakhstan, we have students in New York, USA, who and in different Russian cities and towns, in Yekaterinburg, in St. Petersburg, who join classes from their home places. And I think it's great. We are going to continue this experience. We want to see how this could be incorporated on the regular basis. You can guess that initially we wanted this because of some limitations due to COVID situation. This is a very important slide because I wanted to encourage you apply to participate in HSC's Olympiad. It's a competition which will help you avoid portfolio assessment. If you win our Olympiad, and each year we have several winners, it will allow you get into the program immediately. You won't have to do anything. Please participate in the Olympiad. It's a very interesting competition. I know the team who is developing the items for this competition, and they will be really, really interesting. It will be useful experience. And the second event I would like to highlight is a winter school of the Institute of Education. It will be the first winter school, and you can apply till the middle of January, the same as with the HSC's Olympiad. If you apply and if you go through, you will know a lot about our program, and it will help you make a decision based on your own experience, on your own values, and so on. This is a very short slide about enrollment rules. They are mostly the same as the previous year. You can find links and more explanations and rubrics of assessment on our website. I would like to demonstrate a slide with our main subjects and electives. But I would like to tell you that this list of selectives is not full. We have so many elective courses because HSC opens most of its courses to all students from different campuses. And that means that you, being a student of our master program, will have the opportunity to enroll to other courses and select, build your own learning trajectory. And probably this is the end. This is what I wanted to highlight. I would like to ask Mri to explain more, to give more examples of what our students are doing now, and maybe Mri, you could add something to my short speech. I was trying to make it concise.
Thank you. All this information is very useful, and I want to take a few minutes to give you like a more visionary approach in what we're trying to do as a program. And I'm going to share my screens. I have some slides. So when we initiated this program, we wanted to create something like sunlight. We wanted to put together all this energy to study a lot of things, anything that has to do with how the human changes from birth to death. Okay, so we want to understand everything, who we are. Who are we after all? We can make great things and then make terrible choices at the same time. And what drives that? Okay, and to understand that, you cannot just do psychology, or you cannot just do education. You cannot just do biology and so on. We need to understand development, who we are, across the board. We want psychology, we want education, neuroscience, psychometrics, technology, biology. And notice that we have there some of the branches missing, because those might be new disciplines that we don't know yet. This means we give space to new knowledge and new approaches that are not there yet. So biology includes genetics and epigenetics, for example. Technology includes data science. And what we want to do in our program is cover a little bit to give a very wholesome approach in terms of the tools you need to move on to the next step. A master's program is 2 years. You can learn a lot, and my advice would be to learn a lot of methods, to learn a lot of technologies or approaches in looking at information. And then once you have that, you can apply it to anything. So this is what we want to cover. And our approach and our practice is that we want to embrace people that come from all these different places. We have students coming from computer science, and we have students coming from psychology and linguistics. We have everything, and we want that. We have some people coming from I think more management kind of positions or teaching positions, and this is great to see, because we need, the diversity is empowering, because we want people to work together and understand that not everybody should be the same as you, so that you can be productive. Okay, so in that sense, we also teach you different things in education, psychology, neuroscience, psychometrics, technology, biology, and then it's up to you to find your drive in what you want to build more. This is graduate school after all. So then what do you want to be at the end? What can you be at the end? This is a video that some of our students created, and it's only 1 minute. So I'm going to play it because it says everything so concisely and very targeted. And then we can talk a little bit more about what we do in my lab. So this is 1 minute.
As soon as we...
Oh, can you hear it? Okay, here we go.
As soon as we are brought into the world, a lifelong process of learning begins. But how exactly do people develop and learn? What role does genetics play? And what can we do to evaluate patterns in the data and improve our education practices? The Institute of Education and the Department of Psychology at Higher School of Economics are pleased to present a new English master's program, Science of Learning and Assessment. Here, you will have an opportunity to study learning and development across the lifespan in both typical and atypical populations. Our students will gain strong competence in relevant aspects of psychology, psychometrics, and education, as well as deepen their knowledge in neuroscience using cutting-edge methods. You will also study genetics, machine learning, and even more. Such interdisciplinary approach will prepare students for many career paths in academia, government, schools, in app and video game development companies, clinics, or education. Let's make learning and assessment better together. Welcome to our program.
So this is a beautiful video that our students developed from scratch. Wonderful. So this is my lab, and we are contributing towards the developmental science projects. And we also are using psychometrics. We have publications that we applied psychometrics to understand different cognitive processes. So it is true that we can take different things to understand similar questions. And how do we do it? We want to use not just neuroimaging, we also use a lot of psychology and behavioral methods with neuroimaging techniques. We are interested in development, so we're studying children and the changing brain, so our results have implications for educational practice, for clinical practice, and so on. So we are using behavioral methods. For example, we use cognitive tasks. So these are technically games we design that are specifically developed so that we can measure different abilities, how fast people respond or how accurate will tell us about their performance. We also use things like surveys, for example, how we ask children, for example, about their educational engagement. So we ask them about emotional engagement, cognitive engagement, behavioral engagement, all these different things. And this is important because it gives us behavioral scores that we can relate, for example, to brain activity. We use magnetic resonance imaging. This is a nice machine up here. It's really, really cool. It is made up of very strong magnets that can be used to look inside the body. And we take different types of images. I'm going to show you in the following slides how things look like. Anatomical MRIs, we use functional MRIs, diffusion MRIs. These are just different sequences, how we record things in the brain so that we can either see the structure, where the different parts of the brains are, or the function, how the blood is flowing while the participants are playing a game, or they are maybe doing nothing. We call that the resting state functional MRI. We use eye tracking, we use transcranial Doppler ultrasonography. So eye tracking, you can see here with one of our students calibrating the machine. You see the eye there. She was just calibrating. This is a very high precision eye tracker so that we can see where the eyes are looking when you're problem solving. So then we can see and infer, try to understand which strategy you were using or a participant was using when they were playing a game. Transcranial Doppler ultrasonography is like the ultrasound you see a lot in medical clinics. But what we do is we test regular children in schools, totally healthy, and we record from blood vessels that supply the brain. And we record how big the vessels are and how fast the blood is flowing. And then we can actually correlate those values, relate those values with behavior. And that is pretty cool. And we're finding interesting differences between the two hemispheres. With blood velocities and so on. Electroencephalography, it's another neuroimaging method that we can use to answer questions about when things happen in the brain. For example, when we see a picture, when does the reaction happen in the brain? When do we see that? Or when we're making a cognitive decision, when does that happen? And so on. There are other methods, but this is the ones that we're going to talk about today. We do a lot of our MRI scans at the 3 Tesla MRI Philips at the Children's Hospital here in Moscow. And it's pretty cool because we can get images like this. Let me see, can you see the animation? Like now you can see the animation, okay? So you can see the animation going like this from left to right. So you're seeing the sagittal of the brain. And see how beautiful the brains are, the brain matter is. So you see the white stuff here is actually called white matter. It's not very creative in the name. You see more white stuff, you call it white matter. You see more gray stuff, you call it gray matter. So the white matter and the gray matter, and how much folding there is there in the brain can tell researchers differences in the development, let's say, of the brain. So for example, younger children don't have as much myelin, the white matter stuff. It grows with age. And with experience, we can also see this gray matter stuff to change with age, okay? So we can study that and relate it with cognitive performance. We also look at how different parts of the brain are connected. We use diffusion tensor imaging for that. So it's the same machine. The MRI machine is the same, but we scan it in a different way. And we can record and understand where these fiber tracks are. And we can also ask all sorts of different questions. Some of our PhD students are doing really cool work with diffusion tensor imaging. And this is, it's not our image, but this is a pretty image that you can actually create from DTI, diffusion tensor imaging data. Functional MRI is more about the function of the brain rather than the structure of the brain, like what we said before about the anatomical and the diffusion MRI. The functional MRI is more like instead of taking pictures of how things are going, you can more or less create the video of where the blood is flowing in the brain at different points in time. Of course, the high resolution, spatial resolution of MRI is really cool because we can detect these blood flow changes. We don't know exactly what requires the blood to go there in the brain, but we know that when a brain region is needed, more blood flows there. So we're testing children, adolescents, adults, and we want to understand all sorts of different questions. We give them tasks related to cognitive control, or we give them tasks related to mathematical operations. Some of those tasks are pretty difficult, and you will be very surprised that some of our like 8, 9, and 10-year-olds sometimes are doing so good. It is super impressive. We are actually have to make them a separate group. So we call them the high performers, and we want to see where in their brain we see the differences. And this is actually the work that one of our current SOLA Science of Learning and Assessment students are doing. We want to see what those high-performing children are using in their brain to perform so high compared to their peers. So we have a group of high performers and a group of normal performers. They're not low performers, they're just normal. But the high ones, is their brain function different? Are they just faster, or are they more accurate because they use a different strategy? Can we see evidence of this in the brain? So Margarita, who is a current first-year student in the SOLA program, is studying this exact question. We have happy participants at the end. Because we give them their brain and they get the gift, and it's a wonderful experience to come and do an MRI study with us. And this is a real data that we got from these young people coming in the lab. Oh yeah, here's the animated part. And you can create these images. By the way, when you're analyzing, and you can also assign different colors for different activities, just to be creative if you want to. So it's kind of fun. Some of our researchers are using eye tracking. So we want to understand strategies, or whether we can predict accuracy, for example, from just eye movements. And it looks like we can. So we can show a game to somebody and record their eye movements and be able to predict with fairly good accuracy about their performance. Isn't that really awesome? So we are using machine learning to understand those questions. And one of our current science of learning and assessment students will be applying machine learning to understand how different brain areas are connected for using functional MRI data. So transcranial Doppler ultrasound is what I explained before. You can record the speed of the blood, or the diameter of the vessel. And we had data from more than 900 children, for example, and we were able to predict and classify their age based just from the blood flow that supplies the brain. And this was a huge study, and we used machine learning just on blood flow parameters. And we developed some models that can that were better in prediction, and that was really, really cool, because it has application, for example, in clinical practice and even other spheres, like forensics, for example. Forensics has to do, let's say, for example, you have a child that you don't know their age, and they don't know to tell you their age, so you can estimate it from different parameters, and this might be a method that can be used for it. Other neurotechnologies we are planning to use are electroencephalography, where we can answer questions about the timing of problem solving, and electroencephalography has been around for a long time. And there's many ways people have been using it. For example, this is more portable, and it can record, oh no, this is FNIRS, and it can record from 2 children at the same time. And this is a very interesting way to examine learning. This is another way of electroencephalography, where it uses brain-computer interfaces very like online at that point in time to record from the brain and give you some feedback so that you can adjust your behavior just from how your brain is responding. I'm going to skip some slides because this is from other people. It's not what we're doing now. So an ongoing fMRI study we have is where we use, we are recording data from adults and children, and we want to understand when and how things change based on different cognitive processes. This is one of the projects that students are doing, and SOLA students are doing. We have some, when we're doing research, we need to consider a lot of things. There's a lot of trade-offs. And we have, for example, previous developmental studies that have been around for a while, where we are using tasks and games that were designed for adults, okay? So when this happens, it's a problem because it doesn't translate always to the children. So it's better to have a game or a task for a child and then transition it to an adult game than the other way around. So when we're doing our training of how we can apply neuroimaging methods, we do take a developmental perspective, because receiving training of how to work with adults does not necessarily give you the tools to work with children or older adults, the elderly. But when you learn how to work with different ages, then you can also work with young adults. Okay, so our tasks have been designed and validated for children. Now we take a developmental perspective, so we don't just look at one age group, we want to look at different ones if possible. So different studies can use different age groups to better understand what we're studying, and so on. So this is one of our pretty games that we are using. I'm not going to go too much detail on this. But overall, there's many exciting stuff that we can study. We also want to link biology, not just from what we see from neuroimaging methods and from neuroscience, but we want to link genetics in the question. Do we have some genetic phenotypes that relate with this outstanding performance, for example, or with better performance in math, and so on. So these are projects we are working on developing. So with that, I'm going to stop and I'm going to open the floor for questions.